Welcome, guys and gals. We're back with functions. Let's see if I can zoom out just a little bit. There we go. So we're back with functions, and we're talking about rate of change with equations and word problems. Now, notice the slight change, in our wording. Rate of change. In our last video, we were talking about an idea called slope. And we said that slope was how we would describe our linear functions and how they would change on a graph. So for example, if I drew a real quick XY axis here and I had my graph there, and let's see our equation graphed a line, maybe it looks something like this. So it's got positive slope. All right. We said slope describes how steep our line is. So whether our line is, say, trending up, or let's draw another one here real quick, whether our line is trending down. So maybe our line looks like this for this particular slope. All right. And we discussed a mathematical way of coming up with that number, our slope formula, and we said it looks something like this. So jot this down again so that way you've got it on both sets of notes. We said m represents slope. Why it was given that variable, who knows, who cares? And then the formula looks something like this. We take our y coordinate for the second point and subtract from it the y coordinate of the first point. And then, of course, the x coordinate for the second point is subtracted by the x coordinate of the first point, and we end up with this fraction. And remember, we said it was okay to leave these as fractions. Of course, they could be whole numbers if we reduce. As best we can, we want to steer clear from decimals unless we're just forced into it, like if we're talking about money. But that's how we dealt with slope. So today we're going to change gears just a little bit, and we're going to talk about this idea of rate of change. So what's the difference? How does rate of change compare to slope? And the real simple answer is they are the same. These two ideas talk about the exact same number, but here's the real difference. Slope is typically reserved when we're talking about the line itself, what we've graphed. Rate of change, however, is when we're dealing with a specific context. All right, context meaning something that's happening in the real world. All right. For example, I could tell you that the rate of change in a particular, or excuse me, that the slope rather in a situation was, say, 10. Cool. So I have 10, and that is my slope. So if we were to graph that, it would be a line that would be fairly steep, right? But if we're talking about context, then I could talk about $10 for every 1 hour, and suddenly we have a rate of change. In other words, we've got a real world situation. I'm making $10 for every hour that I work. All right, suddenly I know exactly what that number 10 means. It's not just some random slope describing some random line on the page. It has real world meaning. So today we're going to focus on word problems and equations to help us find this idea of slope or rate of change. Now you'll understand, I will interchange these two words. I'll use them interchangeably simply because when I was a student, we really didn't talk about rate of change. We only used the word slope to kind of help distinguish between what we're discussing, whether we're talking about just a line on a graph or if we're talking about some context. We're going to try, or at least I'll try as best I can, to distinguish between rate of change if we're talking about something we know in the real world, or slope, just a number that we have to describe that line. All right. So let's take a look. How do we find rate of change in a word problem? All right. So let's read this first word problem, and then we'll talk about how to do it. So it says, Mr. Lamar decides to work at McWendy's on the weekends. He earned a sign-on bonus of $50 and will make $10.50 per hour. What is the rate of change? All right. Some word problems are going to come right out and tell you. So the trick to finding it is simply look for a rate. And remember, rates come in lots of different forms. For example, I could talk about miles per hour, so that rate is a speed. I could talk about words per minute, okay? And notice that would be, say, like a typing speed. Or in this situation, we're talking about how much money I'm going to make per hour. That's my rate. I'm looking at the amount of money over the amount of time I am working. So my rate in this case is dollars per hour. Now, one thing that we need to remember is that when we have a rate, all right, also known as a slope, we set it up so that the dependent variable is on top and the independent variable is on the bottom. So notice, in this case, the amount of money I make is dependent upon how much time I work. If I only work 1 hour, well, then I'm going to make very little money. If I worked for, say, 100 hours, well, then I would get much, much more. So dependent on top, independent on bottom. And remember, time is almost always independent unless you've got a DeLorean. So if you don't know that movie reference, get out from under that rock you're living under. So take a look. Let's see if we've got a rate in here, and let's see if we can pinpoint it. So the first number I happen to see is a sign-on bonus. Now, if you've ever had an older sibling or maybe a parent that's gone and gotten a job with a sign-on bonus, this is a one-time thing. All right, they're only going to give me that $500 once just for signing up to work for them. That is not a rate. It's not describing any sort of change. So this, nope, not it. Let's keep going. And it says that he will make $10.50 per hour, right? This word right here is what I'm looking for. When I see the word per, all right, we're not talking about a cat, we're talking about a rate. Miles per hour, words per minute, dollars per hour. So that tells me that, hey, I've got a rate. So in this case, $10.50 per hour. So what is my rate of change? Well, put simply, I could write it out as $10.50 for every 1 hour. Now, I know what some of you are saying. Wait a minute, Mr. Lamar, hold on. Up here, you said we need to make it a fraction and we need to stay away from decimals. And I would agree with you. However, in the real world, there are some things that we just don't measure as a fraction. And in this case, our monetary system, our money, is not one that we do that with. So in this case, we will kind of mix our fraction with the decimal simply because that's how our money system works. If our monetary system was based in fractions, well, then we would use that. And as best we can, we'll try to stick to fractions. But in this case, it's a decimal. We're kind of stuck. All right, let's try another one. Mr. Moss, oh, bless his heart, Mr. Moss. Mr. Moss needs to rent a car to drive his cat across the country. The car will cost $250 for 3 days. And if he needs the car for 5 days, it will cost $350. What is the rate of change? Notice, in this case, I don't see words like per. So this first method of finding it, just simply looking for that rate, isn't going to work. There is no rate given. So let's jot that down real quick. In this case, there is no rate given. So I have to calculate the rate. All right. So if the word problem doesn't come right out and tell it to you, then you get to calculate. And the way we're going to do it is with our slope formula. Remember, slope and rate of change are the same thing. So I'm going to use the same formula. So let me jot it down. So my slope is equal to y2 subtract y1 over x2 subtract x1. So what I need to do is I need to figure out what are the coordinates and what's independent and what's dependent. All right, so let's look at our situation. We know that we're going to be spending money on the car. All right, so that's come up a couple of times. We also have time, right, measured in days. Remember, time is almost always going to be our independent variable. So this 3-day time period is an X. This $250 is Y. So this is an ordered pair. So my first ordered pair, and I'm going to write it off to the side here, is for 3 days. It's going to cost Mr. Moss $250 to rent the car. All right, let's see if we've got any other points. Because remember, we need to find slope. Or excuse me, in this case, rate of change. So let's see. Then it says if he needs the car for 5 days. So notice that 5 days is an X, and it will cost $350. That is a Y. So there's another ordered pair. So if he were to rent it for 5 days, then the cost will be $350. Notice now I've got my two coordinates. I can use what we did last time and come up with our rate of change. So let's figure it out. I'm going to let this first one be coordinate 1 and the second one be coordinate 2. Remember, we always want to identify. So the first thing I need is y2. So in this case, 350. So let's write that down. 350. Subtract y1. Well, that's 250. Over x2. In that case, this is 5. Subtract x1. All right, well, that's a 3. And let's see what we get. 350 subtract 250. Well, that's 100 the last time I checked. And 5 subtract 3, that is 2. Now, remember, we're talking about real-world situations here, so we need to be able to know what are we measuring. So remember, the 350 and the 250 were dollar amounts, okay? And the 5 and the 3 were the number of days. So one way to talk about this rate is that it's going to cost him $100 for 2 days. And that's a perfectly fine rate, but notice that fraction, 100 over 2, could be simplified. And if we do that, it's going to make this number mean a lot more to us. So let's do that. I know that 100 divided by 2 is 50. So a better way to describe this particular rate is that it's going to cost Mr. Moss $50 per day. All right, so we can write it that way as a fraction, or we could say the cost is $50 per day. So we could write our slope, or our rate of change rather, as a fraction like this, or we could write it in a word form like that. Notice we've got that word per in there. That's one way that we indicate that we're talking about a rate. All right? So let's review. Sometimes our word problems will come right out and tell us, and we just have to look for it. All right? Sometimes the rate isn't going to be handed to us, so we're going to have to calculate it. Remember, we'll use our slope formula. And again, we'll find that rate just fine. Let's do one more. It says, Mr. Morse plans on working at summer school. Well, good for him. He's going to start with 20 students in his class. All right. It says students may stop attending when they are passing. By day 5, he has 13 students. All right. What is the rate of change? Well, let's look back. Do we just simply have a rate that we can find? Well, as I'm reading through this, I notice I don't see a word that would describe a rate. I know that we have 20 students or that 5 days have passed, but I really don't see a rate. So it looks like we're going to have to go with the second option. We're going to have to calculate it. So let's write out our formula again, just so we can see it. So it's m equals y2 subtract y1 over x2 subtract x1. So what I'm going to have to do is I'm going to have to figure out what's independent and what's dependent. Remember, because dependent goes on top, independent goes on the bottom. Well, one point that I can see very quickly is that we're talking about days and students. And it would appear that as days pass, the students are dropping, right, in their number. So this would be my x, and this would be my y. So one of my coordinates, and I'll write it over here on the side, is that after 5 days, only 13 students now remain in the class. So we need another point, right? We need another coordinate, an ordered pair, to be able to do our slope formula. But I notice up here he starts with 20 students. Okay, well, we can put our 20 in. But the question is, what should the number of days be? Well, if he's going to start working, and let's say the people in the office hand him a list of students with 20 names on it, that means no time has passed, right? He hasn't worked summer school yet. He hasn't started yet when he gets those 20 students. So what we'll do is we'll put a 0 in here to represent our starting point. Because think about it, if we're at a race, let's say here we are, we're at a race, and we're on the starting line, that's a terrible person. We can't claim that we've been any distance yet, right? For all we know, by the end of the first day, maybe a couple kids pass, so he doesn't have 20 kids anymore. So this would be at the 0 mark, and then as you run your race, then you can hit, say, 1 mile, 2 miles, and so on. So since he's just starting, we'll put a 0 in for the x. All right, so let's find our slope. We'll let this be coordinate 1 and coordinate 2. So I need my 13 first. Let's write that down. So this equals 13 subtract 20 over, let's see here, 5 subtract 0. So that part's going to be easy. All right, so 13 subtract 20. Well, I know that's going to be a negative number here. So let's write it down, -7. And then 5 subtract 0, of course, that is just 5. Cool. So what does that mean? Well, obviously it's a negative slope, right? So that means we're losing students, and that's what's to be expected. It says they can stop attending when they pass. So if they pass, they no longer come. But what does that -7 mean? Well, in this case, remember, dependent over independent. So my dependent is the number of students. So -7 students for every 5 days. Huh, that's kind of weird. How do I lose 7 students? Well, in this case, we don't mean lose as in they're lost at the mall. We mean that they're no longer coming to class. So if we're going to write out this rate of change, I'm not sure a fraction rather is the best way to do it. I think I'm going to write it in words. So I could say, what's the rate of change? I could say the rate is that Mr. Morse will have 7 fewer students every 5 days. And notice by saying fewer, we're implying that negative, that we're going to lose those kiddos as we go along. So when we see word problems, this is how we do it. Sometimes they're going to come right out and tell us, so it's just a matter of you looking for it. Other times, like these 2 examples, we're going to actually have to calculate that rate of change. All right. And again, we'll use that same slope formula that we saw before, because remember, slope and rate of change are identical. All right. Well, let's talk about equations. Word problems are pretty straightforward. Equations, believe it or not, are even easier. So take a look. Finding rate of change in equations. So the first thing we need to talk about is the format. This is a general format for linear functions. Write that down. And what I mean by linear functions is that when we graph things like, oh, my situation where I'm making money, or Mr. Moss's situation with the car rental, or Mr. Morse's situation at summer school, they would all graph out as lines. For example, my situation here would look something like this. For every hour I work, my money, so this is hours, every hour I work, the amount of money will go up by 1050. Or here, say for Mr. Morse, his graph would look something like this. He would start with 20 students, and then his line's going to go down, right? For every 5 days, he'll lose 7 more students. And eventually he'll get to a point where he has no students at all. These equations are the algebraic way of describing what we see in the graph or what we see in words. So let's talk about what it means. All of our linear functions are going to look something like this. Remember, where y is the dependent variable, x is the independent variable, and m, we've already talked about that variable. This is our, I'm going to call it slope because I don't have a lot of space here. We could also call it our rate of change. Now, b, what in the world does that stand for? Well, b, for right now, is just going to be a number, okay? And we'll talk about what that number means later on. But for now, just know sometimes we'll have a number and sometimes we won't. So the way we find rate of change in equations is simple. Find m, all right? Whatever number sits in front of the x, that's your rate of change. So let me show you how it works. Here's a function to describe a real-world situation. The x's represent, remember, independent is the number of shoes. So maybe it's the number of shoes that maybe a company is making. And the y represents the cost, maybe how much money it costs to make the shoe. Who knows? If I'm going to find the rate of change, it's the number in front of x. So right here, there it is. So my slope, simply put, is 4. Okay. If we're wanting to know the rate of change, well, remember, rate of change is dependent over independent. Well, in this case, y is dependent, so cost. So if I were to put it as a rate, I would say that this is $4, right? Cost, we're measuring in dollars. If we were in Russia, we'd measure in rubles. Over our independent. Well, independent in this case is shoes. Well, what numbers should I put here? Well, if I want to write 4 as a fraction, I could simply write it as 4 over 1. So in this case, the cost, if we're going to write it as a rate, is $4 for every shoe that this company makes. And let's hope they're not making terribly fancy shoes, because at $4 a piece, they're not going to be very good. But there's our rate. So slope is just a number, the 4. If I want to write it as our rate of change, then we need to be specific. In this case, $4 for every one shoe. All right, let's try another one. So notice, y equals m. This is the m. It's the number in front of x, so this is our slope. So if all we're asked for is the slope, well, cool. Our slope in this case is just the -3. All right. If we want to know the rate, all right, our rate of change, then we're going to have to be more specific. So let's look at what we've got. X is independent, remember. So X is the number of chocolate bars, okay? And Y is the number of days. Well, notice this slope is negative, so it looks like we're losing chocolate bars. So maybe we've got a situation where maybe we've got a house full of kids and they're eating them, maybe after Easter or something. So let's write our rate out. All right, so remember, it's dependent over independent. So Y is the number of days that have elapsed, where X is the number of chocolate bars that we've got. I think I may have that written backwards, actually. I think X should be number of days. Y should be the number of chocolate bars. Yeah, because remember, days are almost always your X variable, and in this case it should. I must have mistyped that. So no harm, no foul. We can change it out. So X is the number of days that have elapsed. That means Y is the number of chocolate bars. So I've got a -3, so -3 bars of chocolate for, and again, if I were to write 3 as a fraction, it would be 3 over 1. So 3 bars for every 1 day. Now, -3 bars sounds kind of weird because we don't really measure chocolate as a negative. I mean, after all, chocolate's one of the most positive things on earth. So writing this in words would probably be a better way to go. So I could say, maybe we eat 3 bars each day. Maybe we've got a house, full of 10 kids or something. So 3 bars of chocolate's really not that big a deal. So we eat 3 bars each day. So that would be a good way for us to describe our rate of change. All right, let's look at another one. Well, this one's kind of weird. Notice if I were to graph this first one where X is 4, let's just draw a real quick XY axis here. If I were to graph that one, it would look maybe something like this, right? Because 4 we said would be sort of a steep line, right? This case, where our -3, all right, if we were to graph it, it might look something like this, right? Where we're trending down 3 each time. But notice this one. This time, my m, my rate, my slope is a 0. So take a look. In this case, my slope is a 0. If I were to graph that, it would look something like this. Remember, we said that if we have 0 slope, it's just a flat line, horizontal. All right? So if I were to write this rate, let's see what we've got. It says X is the number of hours worked, and Y is the money earned. All right? Well, remember, dependent over independent is how we write our slopes. So let's figure it out. X is hours worked, so that's independent. Y is the money earned. So take a look. In this case, I would have $0, and then X is the hours worked, so over every 1 hour. Ugh. So let's look at this situation. It looks like this person is making $0 every hour. Yikes, that's not a great way to work. So we could write it this way, $0 per hour, or we could write it in words. The person makes $0 each hour. And maybe that's a situation where maybe they were going to pay you just a one lump sum. So it doesn't matter how long it takes. You're not making an hourly rate. So maybe you're a salary situation. But that's what it would mean. Now let's talk about this last one. So far, all of our equations have looked like this y equals mx plus b. Sometimes we'll get a situation like this, where notice it's not y equals mx plus b. All right, so here's what we're going to do. We're going to rewrite this so that way it looks like y equals mx plus b. In other words, I want to get this to look like that. In other words, I want the y to be all by itself. So if I were to solve this for y, it means 3x needs to go first. So we're going to solve this equation just like we've done every other equation. So I'm going to subtract 3x on both sides. Let's do that first. 3x subtract 3x is 0, so that means 4y is left. Over here, 3x and 120, they are not the same value, right? They're not the same. This is a 3x, that's a 120, so we can't actually subtract. So I'm going to write it as a negative 3x added to the 120 that was already there. So, cool. But notice y is not by itself. I want it as y equals mx plus b, not 4y. All right, so I got to get rid of that 4. Well, the 4 is multiplied by the y, so to undo it, I'm going to divide everything by 4. All right? Well, 4 divided by 4 is 1, so we'll get 1y. Now, 3 over 4, I could type that in as a decimal, but remember, this number next to x is the slope, and we said slope is good as a fraction. So I'm going to write this as just negative 3 over 4 as a fraction, x. So that way I don't have to do the division. Plus, it's okay. We're fine with rates of change being this way. Plus, then we need to take 120. We can go ahead and divide that by 4. 4 goes into 12 3 times with that extra 0, so 30. Cool. So my slope in this case, if we just want to write it as a number, is negative 3 over 4. So negative 3 over 4. And let's see if we can get the rate out of this. So it looks like x is our independent. It's the number of boys in a situation. Okay. And y, the output, is the number of girls. All right. So if we were to read this rate, remember, we're going to put dependent on top. So negative 3 girls for every, looks like 4 boys. All right. So the way we could read that rate is that if 3 girls don't show up, then maybe 4 boys do. Okay. And maybe we're talking about a situation where maybe there's a, I don't know, make something up. Maybe there's a field trip. And if these 3 girls, for every 3 group of girls that don't go, maybe 4 boys are able to sign up for some reason. Who knows? This is kind of a weird rate. I found it out of a book. But again, that's how we would read that. For every 3 girls that don't show up, 4 boys will. Of course, we could rewrite that another way. We could write it as 3 girls for every negative 4 boys, and it would mean the exact same thing. So if 3 girls do show up, and that means 4 boys don't, or whatever, and that's fine. But again, slope is just a number, whereas rate of change is where we're going to start putting that context to it. All right. So notice this next one says find the rate of change for each equation. But notice we really can't find a rate per se because there is no context. So again, that y equals mx plus b, what we're looking for is this number in front of x. In other words, we're really just looking for the slope. So let's take a look. We'll do it real fast. If there is no number, notice this first one, no actual number written there. Anytime you've got a variable with nothing in front of it, no coefficient, we assume that there is a 1 sitting there because 1 times x is just x after all. So in this case, my slope is a 1. Cool, easy. All right, let's try the next one. Y equals 30x plus 10. Remember, the number in front of x is our slope. So this time, they gave it to us straight up. So in this case, our slope is a positive 30. Cool. All right, our next one. Notice the number in front of x is the slope, so 1/2. So the slope is 1/2. Now, some people ask, could we write that as a decimal? Again, it depends. Remember, if we're talking about, say, a money situation, well, then maybe it makes more sense to write it as the decimal. If it's not, then we want to try and keep it as a fraction, if at all possible. All right, this next one, we've got 5 over 4. Notice that's an improper fraction, and we're okay with that. Slopes can be improper. So in this case, 5 over 4. And remember, we're not going to pay any attention to this other number just yet. We don't need it for now. We're only looking for slopes, right? This one over here, again, no number written there. So we assume that it's a 1. All right. So our slope in this case, -1. Now notice this one. This one's kind of an odd duck. Put a star beside that one. Notice there's not even an x. Let's think about this. What number could I multiply by x to make it simply go away? Well, the number that comes to mind is 0. Notice that if this equation here, y equals 5, was rewritten, I could write it as 0x plus 5, because what's 0 times x? Well, 0 times any number is just 0. And 0 plus 5 is just 5. So notice y equals 5 is the same thing as y equals 0x plus 5. So anytime you have y as just a number, we know that the slope will be 0. In other words, it's going to graph like this. 0 slopes are horizontal. So in this case, no x's, cool. Our slope is 0. All right, so this is what we'll be doing today. Still looking for that slope per se, but today we're going to be focusing a lot more on context. What do these numbers actually mean? And if we've got a situation, well, cool, then we'll try and figure out what it means. If we don't have a situation, so no context, well, fine, we'll just write the slope same as we've been doing and we'll be fine. If you have any questions or concerns, please bring them with you to class and we'll talk about them. Have a good day, folks.